Hey everyone, welcome to P3 Part 2. This is going to be classification of functions. First in your book on page 23 and 24 are some pretty important stuff. Actually, I even put it up here. So here's one that you should know. You should know this kind of stuff. Let's just make it a little bit bigger here for right now. You should know lines, parabolas, cubics, square roots, absolute value, rational functions, sine and cosine. These are ones you should just know what they look like. I'm not asking you to graph them perfectly, but you should know what a line looks like, what a parabola, what a cubic, square root, absolute value, rational, sine, and cosine. Alright, so make sure you know those. They are on page 23. And on page 24, here are just some rules on the families of graphs of how to move them left and right, up, down, rotations, flips, all that kind of stuff. So you should kind of know what happens to a graph here. And this is the idea of what those types of shifts do, or reflection. So you should know all of this stuff. Alright, so make sure you know all of 23 and 24. Now let's get back to it. That's not what we want. We want this guy right here. Okay, so elementary functions is what we're going to talk about, and there are three types of elementary functions. The first type is algebraic. Alright, algebraic is polynomial, radical, or rational, and a rational function could be something like f of x could equal g of x over h of x. So we could have a function divided by another function. It might be a number, it might be all sorts of stuff. So it doesn't have to be just 1 over x. It could be x squared plus 5 over x. Alright, and there's the second type is trig, sine, cosine, tangent, all the stuff we learned about last year. And number 3 is exponential and log. The two types that are not algebraic, trig and exponential, are called transcendental. Transcendental. S-C-E-N-D-E-N-T-A-L. Transcendental. Right? I don't know why you need to know that, but in case you see something with transcendental, you know it's not going to be one of these. It's either going to be exponential, log, sine, cosine, tangent, trig. Okay, so let's talk about polynomial functions. These ones are the ones that we've been talking about a lot. And these are stuff we've kind of already seen before, but this is a good refresher. So if f of x equals ax to the n plus bx to the whatever and whatever, we can keep going. We don't care about any of this stuff. This is the only thing we care about, that highest exponent. Alright, so we know if n is even and a is greater than 0, that means you're going to end and start up. Alright, the middle of this graph might wave around a lot, but we don't really care. All we're talking about is the end behavior. We care about this part, and they're both going up. If a is less than 0, they're both going to be going down. Alright, there might be some waves in here. It might just be looking like a parabola going down. Alright, if n is odd and a is positive, it'll go something like that. Like a line does that, or a cubic. And if a is negative, it's going to do something like that. They may not have that many waves, but that's what we're looking for. We're looking for this end behavior. They're going opposite directions. That should be a review, but you might want to be able to use that just to help you graph some stuff. Alright, let's go on to a few examples. Let's look at composite functions. So example 1, given f of x equals 2x minus 3 and g of x equals cosine x, find f of g. Remember, there's a couple ways of writing that. F O G. It's not fog. It's f of g, which really means we have f of g of x. All right, which means we're taking this g and plugging it into that x, wherever that x is. Every time you see an x, you replace it. So that means we're going to have 2 parentheses cosine x minus 3. Right? We don't really need that parentheses anymore, so it's going to be 2 cosine x minus 3. Okay, so now let's do the other one. If we want to do g of x, we're going to say cosine of 2x minus 3, close your parentheses. That's it. We can't really do more than that, so we're just going to leave it. Okay, notice how this and this are not the same, so the order does matter. Alright, so next we're going to talk about even and odd functions. Okay, if you remember, if you think back to that last page that we just had, even functions were the ones where the even exponents kind of went the same way, the odd functions went the opposite way. That's kind of the same idea. However, they're kind of centered around the origin. They're centered around the x or the y-axis right here. So we want to kind of be careful about that. So an even function, there's a function. It's going to be even if you put in a negative value for x and you get the same value out. So if we put in a negative 3 right here, do we get the same value? We plug in positive 3. So this one and this one have to match up. Then it's even. All right, and that's for all of them. That's not just happen to be that one case, but it has to be for -1 and +1, -2 and +2, -10 and +10. All right, and an odd function, if you plug in the negative value for x, you get the negative value for y. So let's say right here, let's say this was x is 1, 2, 3, 4, 5. X equals 5, and up here is y equals 3. When I plug in x equals -5, this y has to be a -3. All right, so that way with the x's switch, the y's also switch. That's an odd function. The even functions, the x's switch signs, the y's do not switch signs. Odd function, the x's switch signs, and so do the y's. Here's our example. Determine whether each function is even, odd, or neither. So if I have f of x equals x cubed minus x, the first thing I'm going to do is I'm going to plug in a negative value for x. I'm just going to make it negative and see what happens. So we're going to say f of negative x equals negative x cubed minus negative x. All right, good. So now, could I take a negative value out from this? Sure. So that means I can say this is going to be negative x cubed minus x. And isn't that just the same as negative f of x? Which, if we look at, is f of negative x equals negative f of x. So that means this one is an odd function. All right, now let's try this one. G of x equals 1 plus cosine x. So g of negative x equals 1 plus cosine of negative x. Now, if you remember back to your unit circle, when we had a positive value, cosine is the x value. So this one would be the negative. When cosine is positive, negative, positive, negative. And if you can see, they all match. Whew. I'm allergic to good stuff. All right, so the cosine of negative x is the same as cosine of positive x. So we can say this is the 1 plus cosine of x, which is the same as g of x. So the negative is the same as the positive. We're going to say that this one is an even function. All right, there you go. Good luck.